Okay, so you have hopefully been reading about the uniform distribution, and you made it to practice problem number 2. It says the San Diego Unified School District began this academic year on August 26, 2019. The age of a first grader on this day is uniformly distributed from 5.65 to 6.65 years. So, of course, they have rules. Um, First graders have to have their birthday fall within certain dates. Um, and so it spans 1 year, right? Okay, so any first grader on the first day of school will be somewhere between 5.65 and 6.65 years old. That's going to serve as our A and B in our uniform distribution. So we're going to say, okay, everybody falls between these two ages. Obviously, it's not to scale. So where are they in that rectangle? By the way, I didn't note it, but the height of the rectangle is the function f of x 1 over b minus a, which in this case would actually just be at 1. But we're not being asked anything about that. That's not relevant for the questions we're about to see. In part A, it says, if on the first day of school a first grader was randomly selected, what is the probability that he or she was less than 6 years old? Okay, so we've got our formula for the uniform distribution for the probability, right? We still think of it as the probability, P, of capital X less than little x. And here it is, and we can plug in our A and our B. So in this problem, they're asking the chances that somebody is less than 6 years old. Capital X is less than 6. That goes in for our X. And our A goes in both these places and the B there. So if we can figure this out, then we've got the probability. And it turns out for this particular problem, that denominator is just 1. The numerator is 0.35. So the chances of any randomly selected first grader being less than 6 years old is 0.35. And if I went back up here and I drew the line at 6, I think it's a little bit further this way. The chances that any randomly selected first grader falls in that zone, 35%, 0.35. Okay, pretty straightforward once you get familiar with how these formulas work. Part B. What is the probability that a randomly selected first grader was exactly 6 years old? And it's implied exactly 6 years old when the academic year began. So they have these cutoffs. What are the chances that a kid is exactly 6 when they start the new academic year? Okay, so here's kind of that kind of bizarre, difficult conceptual thinking comes in. We only have a formula for when it's less than. If it's equal to, I'll pause. Do you know what the answer is? If capital X is ever equal to something, the answer is always the same thing. Here's what I'll give you a moment to consider it if you don't know. We're thinking at 6. So if we draw that same rectangle as above, I didn't label the A and the B, but they're right there at 6. What are the chances that a randomly selected kid falls perfectly on that line? Well, there's infinitely many possibilities. The chances of getting exactly 1 out of infinity, is 0. There's a 0 probability, a 0% chance that a kid is exactly 6 years old when the new academic year begins. And that's it. Now you might think, wait a second. Are you telling me that no kid happened to have their birthday on the first day of school. Of course, at least somebody is going to have their birthday on the first day of school. They would be exactly 6, wouldn't they? No. When we say the beginning of the academic year, remember, we're thinking continuous random variable. We're not thinking just the day. That would be thinking of it as in a discrete sort of a way. This day, then this day, then this day. We're thinking continuous. We're thinking, what are the chances that someone's birthday, I shouldn't say even birthday, that's confusing. What are the chances that somebody turns 6 at exactly the same instant the new academic year begins? So the first bell rings for the academic year to begin on that morning, whatever, 7:30 a.m., whatever time they start first graders, 8 a.m., I don't know. At exactly the same instant, somebody turns 6 years old. Right at that instant. The chances are 0. It's not going to happen. They might have their birthday on that day, but they're not going to turn 6 at exactly the same instant that the beginning of the day starts. Okay, so in any event, if capital X is ever asked to be exactly equal to something in a continuous random variable, answer is 0. It's one chance out of infinity. It's not going to happen. Then we come to part C, and we've got another percentile question. What was the 80th percentile of the ages on the first day of school? Percentile, we saw one of those a moment ago. We're thinking, what are the chances, or what is the age of which 80% or less? I'm getting this all mixed up. What age marks the 80% of the students? So at that age, 80% of the students are less than that age. I think I almost had it in my first explanation. I'm going to write it out again at the end here. So hopefully that's clearer than what I maybe just spoke out loud. Anyway, the mathematical procedure is this. We're going to take our probability formula, set it equal to 0.8, 80%, solve it for x. Well, in this case, we've got our x. We're going to solve for that. We've got our a and our b all plugged in. What value of x would make this whole thing equal 0.8 probability? Well, again, in this case, our denominator is just 1. And so it goes pretty smoothly. We're really just asking x minus 5.65 equals 0.8. If we add the 5.65, x equals 6.45 years old. So that age, 80%, I've got it down here, 80% of first graders are less than this age on the first day of school. It marks the 80th percentile. So 80% of those first graders are that age or less at the moment when school begins on the first day. Okay, well, that is practice problem number 2. We've got just one more in this chapter, pretty short chapter. So I'll see you for practice problem 3, which is the very next question. You don't have to read anything. See you then.